Hey, it's Greg Spencer, and we're here to talk about radon today. We're going to do a test on an actual house. This one happens to be a 1960s ranch house with a full finished basement. Radon is recommended for every house, but we are going to begin a test at this one today. Okay, we're here down in the basement, which is typically where radon testing is performed in a house with a basement that has livable space. This one is a fully finished basement, as you can see, but basements don't have to be fully finished in order to be tested. EPA protocol recommends testing at the lowest level of livable space, and someone may have an exercise bike or like to tie flies in the basement or a pottery studio or whatever. Can be crude, but as long as it's a space that can be occupied for any period of time, that is the location where radon should be tested. Crawl spaces are not tested. Houses that are over a crawl space are tested on the main level above the crawl space. I brought a variety of testing devices here today. These two are manufactured by a company called Sun Nuclear. This model is a 1028, and both of these electronic devices, and I'll distinguish the difference between passive and active devices. These are both active devices and take a reading every hour over a minimum 48-hour testing period. This 1028 actually produces a graph of the readings over that testing period and is an excellent device. This one is similar. It's a 1027 and also takes a reading every hour over the testing period, then prints that out. The only difference is this one provides the graph. This one just produces a chart of the readings. Both are very accurate. They are also tamper-proof, so that if power is lost or they are moved, or there's a change in temperature and humidity, that will be detected and reported in the printout. So excellent devices for use in a real estate application. This is what's known as a passive device. Typical charcoal canister, looks like a hockey puck. These are acceptable for use in a real estate application. However, there should be two co-located devices when used, meaning that they are to be placed side by side 4 inches apart in the testing location. In order to deploy these devices, one simply removes the tape. And it's very important to save the tape because these canisters are weighed by the lab and then they are weighed again when they are received back after the testing period. And so we typically just take the tape and wrap it back around the canister after we have removed the lid. That way it doesn't get lost or damaged. So we do that with both devices and we place those for the testing period. These devices record when they were deployed. These devices obviously do not, so it's very critical that this reporting sheet be completely filled out by the testing professional and sent into the lab with the test. Big difference here is that these devices only produce one level. They are deployed for a minimum of 48 hours, maximum 96 hours. And then after that testing period, they are then closed back up, sealed, same tape, well sealed, and placed back in the box with this fully completed as to the date, start time, date, stop time, and other information about weather and wind and exactly where they were located. So I didn't open and close this one for time purposes, but both of these would be treated the same way, put in the box, mailed to the lab. The lab would then email the results back. these are typically sent by U.S. Postal Service, so there is a time delay. Another big difference in a passive device and an active device is that this has instantaneous results, this does not. So our firm, 98% of the time will use one of these active devices because A, they're more accurate, B, they are tamper-proof, and C, they are quicker. We can get the results on time within the typical tight due diligence. Okay, so with any device, we are required by the EPA to post a notice for the owner or occupant of the property stating that the test is going on and ensuring that we maintain a closed house condition. There are several other effective methods to ensure that a closed house is provided during the testing period, including tamper-proof tape, getting the seller to actually sign that they complied with the protocol, etc., etc. So anyway, the test then is deployed, and when one of these monitors is used, we push a combination of buttons to clear it, and then start the test, tell it how long we want, what intervals we want, and how long we want that test to run. Now the difference, another key difference is this can only run for 96 hours, 4 days. These can run up to 42 days. And the longer the test, the better, because what we're doing is measuring radon each hour, and then it's cumulative, and those levels are divided by the total amount of testing period. So it's not that the longer the test goes, the more radon is detected by these devices. The longer the test, the more accurate, because it's basic statistics. When we have 48 samples, it means one thing. If we have 480 samples, we have much more data. It's like polling after a presidential election. You ask 10 people who they voted for. That data has a certain accuracy and reliability. If you ask 10,000 people who they voted for, you have a much better, broader sample, and it becomes much more accurate. So we usually try to do the radon test for as long as possible within the due diligence. But in real estate, that's usually not very long. So we're going to deploy these devices and then come back in 48 hours, and we will see what the results were. Okay, we're back. It's been 48 hours, and this monitor is ready to be read manually. We'll plug this into some software, and we'll get the actual hourly readings and the graph. And I can tell by pushing a series of buttons what the actual level is on this test, and it is 3.4, and it's a funny term. It's picocuries, which is 1/1,000,000th of a gram. Kind of a long story, but it dates back to Madame Curie. And so it's picocuries per liter of air. So 3.4 is within the EPA's acceptable limits. Find that a lot of realtors fail to know what the trigger point is with radon levels. It is 4.0 picocuries per liter of air, and that is a somewhat arbitrary level assigned by the EPA many years ago, and has has, there's been a lot of debate about whether that's the right number or not, but for better or worse, that is the number. 3.9 is considered acceptable, not actionable. 4.0 is the trigger point, and anything 4.0 and above is typically remediated. And we can talk a lot about how to remediate and so on, but I want to go back to where radon comes from and why is it a problem, and when was it discovered. Radon causes only one known health problem, and it's a pretty serious one, and that would be lung cancer. To date, there are no other adverse health effects of it, but lung cancer is a known symptom of it, and it's usually taken pretty seriously in the medical community. Radon comes from uranium, naturally occurring in the soil. Uranium, the same material that we use for nuclear weapons and nuclear power plants, and it can occur in one house, but not in the one next door. There are certain neighborhoods or locations in cities that are sort of known areas with elevated radon levels in many of the houses. But regardless of that, the EPA recommends testing every house, and that is the recommendation that we give to our clients. Radon can be mitigated very effectively and relatively inexpensively by a technique. The most common technique is sub-slab depressurization when it's in a finished basement like this. If radon is also coming from a crawl space, and houses with part basement, part crawl spaces are a very high configuration from a construction standpoint for elevated radon levels, and that is called, in the crawl space portion, submembrane depressurization. Basically, a thick membrane is applied over the crawl space, and then radon is sucked from below that membrane in the crawl, sucked from below the slab in the basement, and then vented outside. And again, there's protocol and standards for how that should be done, and it's tried and true technology. Doesn't always work the first time, and depending on the level and the house configuration, it may take a couple of attempts, maybe 5 attempts is the most I've seen, to get it down below 4. Typical cost of remediation is probably an average of $1,500 in Metro Atlanta, but can go as high as $7,000 or $8,000 in a big house that's very difficult to mitigate. So thanks again. My name is Greg Spencer with Building Knowledge, and appreciate the opportunity to share our knowledge about radon with you.